take two on this. I recorded this long video and then realized that I had actually been streaming it, not recording it. So if any of you were watching my Twitch channel at the exact right time a couple hours ago, you got this video long before anybody else. So um, you've now seen what the pins all do on the microcontroller, and you've downloaded the board definition. So what we're going to do now is we're going to uh, make sure that we can communicate with the board through microcontroller word with our computer. We're going to do that by writing a simple hello world, and this is the hello world of Arduino software. We'll do the hello world of Arduino hardware in the next video. So we have an LED that's built into the microcontroller. It's up here by the USB plug on this side, right there. And that is something that we can control programmatically. You can see here that it's got a fixed definition of LED underscore built in. And that's something that we can write code and address. It's like a variable. It's like mouse X, mouse Y. So except here we can we're referring to that fixed pin that it's attached to. So first off, what we're going to need to do is make sure that we're talking to the microcontroller. In order to do that, we go back under the Tools menu in our IDE, and you'll want to go to Board, and then from here, this is the same place where you went to the Boards Manager earlier. Then you'll go down to the Arduino Embed OS boards, and there you'll select the one that says Arduino Nano 33 BLE. This is the board that you've got, so click on that, and you should be just about ready to go. We've already seen the IDE and what the code looks like, right? You've got a setup and a loop. Setup is similar to setup in P5.js. It happens once when it first starts. In this case, happens once when the microcontroller first gets power. And then the loop, which happens over and over again. It's akin to the draw function in P5.js. You'll notice that these say void, not function. If you write function in here, it won't compile, it won't work. So you need to write void here before defining a function. There are other ways of defining these. This gets into a little bit of the difference between JavaScript and many other languages. We'll talk more about those in the future, but just remember, setup and loop are both they both have a void type before them. So we are fortunate in that there are a load of pre-built examples. And what you should do is you should go under Examples, Basics, Blink. And this will open up a sketch that looks just like this. A lot of these examples, they do what it says on the tin right up at top. So turns an LED on for 1 second, then off for 1 second repeatedly. Again, this is a controllable LED that's on our board, so we don't need to wire anything up. It's a really good way to make sure that the board that you've got works and you can talk to it and you can change things. So here on the setup function, what we're going to do is we're going to tell the board what we want the pin connected to this LED, because it's exposed. It's actually tied to it should be pin, yeah, so it's tied to pin 13, digital 13, right? Uh, but um, but it's also just tied to this LED, right? So what we're going to do is we're going to declare that pin as an output, and we do that by calling pin mode. So we say pin mode, and the two arguments that we give are LED built in, so which pin we're talking to, and then output, what it's going to do. And so when it's an output, we can write a voltage to it, 0 volts or 3.3 volts. There's also input. We'll look at that later on. But right now we're configuring this as an output. So it can write out 3.3 or 0 volts. And so that's all we have in our setup. And then inside of the loop, the thing that goes over and over again, we say digital write, which writes out a voltage, either 0 volts or 3.3 volts. And it writes it out on the LED built-in pin. And when we say high, what it does is this then writes out 3.3 volts, pulls it high, and then delay means that the whole program waits for 1 second. And that means that everything stops. Nothing happens. It holds the state that it's in currently for 1 second. Delay takes an argument in milliseconds. So 1000 milliseconds, 1 second. We're going to change this to like 250, be a quarter of a second. So after 1 second, we then call digital write again on this pin. Then we say low, and what this does is it pulls it to ground. So it becomes 0 volts, and it effectively turns the LED off. We then wait for 1 more second, and then we go back up to the beginning of the loop. This just goes on forever and ever and ever. So what we need to do in order to actually program this, we've selected the board definition in our tools menu. We then need to plug the microcontroller in. And if in this next step, you always make sure that you have the microcontroller plugged in before you do this next step. This next step is choosing which port or your computer is going to speak to the microcontroller on. And what I mean by port is like what is the physical or virtual port that has the USB cable connected from your computer to the microcontroller. So you can only choose this when it's actually plugged in. So we're going to click on Tools, then we go down to Port, and you can see here it says serial ports. One is my Bluetooth port, and then this other one is, it says USB modem 1443.201, and it's for Arduino Nano 33BL8. If you're on, so this is what it might look like on either a Mac or on Linux. If you're using a Windows machine, then what you'll see here in the serial ports are COM ports. It's going to say COM, C-O-M, and like 4, COM7, COM11. It all depends on how your computer is configured. It's always going to be different. This will always be different too, but hopefully it will always say which board you have connected, so you know that you've chosen the right one. So click on that, and once you have, you can check down here at the bottom where my mouse is moving around. You can see Arduino Nano 33BLE on do. So this is the port and the board that I'm talking to. And to program it, I click on Upload, and we wait for a few moments. And you can see here this light is no longer flashing, but it's now sort of fading. It's breathing in and out. And now it has started to blink. So it's like just blinking on, off, on, off, on. So this is happening once every second. If you wanted to try changing things around in here, you can do that. So let's make this a quarter second that it's on and 1/100th of a second that it's off. This is going to flash pretty quick. Hopefully the camera can pick it up. But I'll upload it, and we can see this LED starts to fade, so we know it's programming. We can also see it says uploading right here. When it's done, this will say done uploading, right? And you'll notice that the board right now is not blinking, and instead this LED is like breathing, it's pulsing, right? So sometimes that happens when you upload a new program after like the second or third time you've uploaded the code to your microcontroller after you've plugged it in. So if you ever see that after you've uploaded it and you don't think that your new code is running on it, all you need to do is press the reset button, this thing right in the center. So I'm going to click that real quick, and now I can see the light is blinking really fast, right? So by pressing that reset button, what it does is it forces it to go through the setup and then start the loop of whatever was most recently programmed on there. So yeah, so in the next video, what we'll do is we'll build a circuit with an LED on here, and then we will control that using digital output, and then we'll work on putting in some switches and build it out from there.